Hello everybody. Just waiting for people to come in here in a couple minutes. Apologize for the typing sounds. I didn't realize I was not muted. It's like some kind of fingerprinting, typing sound fingerprinting. If you ever notice me kind of looking a little strange in my stream, like I'm kind of jerking around a little bit and the typing profile doesn't match, perhaps I've been replaced by an AI. Alrighty, 2 more minutes here. So I'm actually just getting set up still. So today I'm going to be going over some packaging stuff, and I'm just building out our new SFU to get ready for that. We'll see how it goes. Just going to hop on the machine we were using last time as well, just to catch up on the last thread of what occurred in last week's stream. Just jump on here. Just to let people know I am live. Okay. All right, I'm gonna get started. So today on Hacking Hubs, I'm your host, Greg Fodor. And if you remember last week, I was working on a new adapter for an SFU that I've been kind of prototyping that uses a WebRTC framework called Media Soup. And so I got very far last week with that. Had most of the functionality working, and the ultimate last piece was getting Turn working, if you recall. And so Turn, just to remind you, is the functionality used to allow us to speak WebRTC over a fixed port, in this case 443 or 80, depending on how things are set up. And it also is an important thing to ensure people can get past their firewall when using hubs. Now, in addition to using that port, it also allows us to use TCP or UDP. The SFU does that as well, so it's primarily about ports, but it also supports both TCP and UDP, like the SFU itself. And so the issue I was running into last week was we were unable to connect to Turn because the let's get this going again here. Because the candidates that were coming back in the WebRTC SDP offer were not the ones we needed. And on the stream, I went and I did a diff against the known working SDP candidates that Janice gives us that successfully negotiates both Turn and non-Turn connections. And I compared them with the ones we had for the new SFU. And the difference between the two was that the new SFU was not including in its candidate list the private IP address, and since the Turn server runs on the same machine and speaks to the underlying SFU over that private IP address, the lack of that candidate meant that we were not going to be able to connect. And so the trick that I had to figure out was, how do I get this new SFU to include both the IP address that the public is a public internet IP address and also the private internet IP address in the candidates. And it actually took a little bit of trickery. I can share how I did it. Now, Janice, the way I was able to do this was very different. So in Janice's case, I had to stop using a feature called the NAT11 something, which basically forces a single IP address to be sent over all candidates. And again, much like in this case, with Janice, we wanted to ensure both private and public IP addresses were advertised. But in Janice's case, the way I resolved it was by by telling Janus to use stun to determine its public IP address, and then also binding to the private IP address, if I recall. And that ultimately results in Janus advertising 2 IP addresses, the one that it sees itself as over a stun, and then also the one that it sees itself on the Ethernet adapter, which is the private IP address. If you look at, I'm on my EC2 box now, you can see the private IP address is the one the NIC is advertising to the operating system, or the operating system has registered with the NIC. And so that automatically comes up in the candidates for Janus. And then in addition to that, the stun configuration forces it to also include whatever stun says that its IP address is, which in this case would be the public IP address, as seen from the internet. So now I have my room back up here. I think this is all still set up right. So this should, I think, ultimately connect to my little SFU here, but my SFU ain't running, I think. So let me just pick it up. Oops. Yeah, so my SFU is installed in here. If you recall, the name is dialog. So I'm going to go ahead and run it. Try again. Sorry, I can go back. You can see I just kicked it off here in the top. And so now my SFU is running. I should see myself being able to get in. And there we go. Right. Okay. And so if you remember from last time, we don't actually get our peer connection up and running until we join, because that's when we start trying to send data. And so you can see here, I'm negotiating the normal setup. And if I go ahead and add my force turn argument, that'll force the use of the relay as the ICE transport policy, if you remember from last time. And that causes only relay candidates to be considered. And now, if I go ahead and refresh, you'll see that I've successfully negotiated my relay. So ta-da, term works, which is great. So that means we're basically at feature parity in terms of connectivity and in terms of client functionality for this new SFU. In the meantime, Kevin Lee is working on a few additional features the SFU needs for us to securely deploy it, specifically adding proper authentication using our JWT, adding the ability to do a hard kick so that people can get kicked off the voice server authoritatively, and then being able to do bidirectional block. So when you block a user in a room who may be doing something you don't like, or they're harassing you or whatever, SFU also will forcibly disable any new voice messaging going in their direction from you as well, since that's something we don't want. So now to show you how I actually trick things, well, before I do that, let me just show you the answer from the server here. This is our SDP, and you can see now it's advertising both the public IP address and the private IP address, the public one being this 3 and the private being this 10.0. And so how did I get that to work? Well, it was a little bit trickier than I expected. I kind of was hoping that I'd be able to just go in and give it a list of candidates or something, but that turned out to not be possible. And in fact, one of the things that can be a little bit tricky with Media Soup is that there's several layers to it. So there's the underlying SFU C++ implementation, and then there's the server JavaScript API that they created. That's a library you include, Media Soup or just Media Soup, I think. And then there's also this SFU implementation, which we are using, which is based upon the Media Soup demo. And that actually has a library called Proto, P-R-O-T-O-O, which implements most of the signaling plumbing. And then there's the actual SFU root code itself, which interprets a lot of it, which basically stubs out all the signaling endpoints and has a little bit of business logic. So the question I had was like, at what level would I have had to extend things to actually start advertising multiple candidates in a kind of idiomatic way that I would be happy with? And it looked like it was fairly deep. I didn't dig fully all the way to see, but I suspect it would require a fork of the Media Soup server API at the very least, if not further. So it was kind of ruled out for me to hack it into our SFU directly. And so that meant I kind of had to come up with a way to trick the Media Soup server to do it. And so the configuration file here is not really a Media Soup configuration per se. It's a configuration file that's specifically a handy configuration format for this SFU implementation that Media Soup has kindly included for people to use. So there's nothing really inherent about this configuration file that's baked with MediaSoup. This is just an incidental format that this SFU implementation uses. So certainly we could use something else, or we could just not have a configuration file. We could burn everything into the code. But this is kind of how this SFU implementation comes out of the box. And it includes this WebRTC transport section, which ultimately gets sent over to the underlying WebRTC transport object implementation, which is one of the server-side implementation abstractions. And you can pass it a list of listen IP blocks, and these map into that server API for setting up the bindings and so on for the listeners for the underlying SFU process that runs, or processes that run. And so previously the way this was set up was very similar to kind of how I originally had Janus set up before we had to incorporate turn. And so initially it had an IP address, which was just the listen IP, and this is the IP that that it was set up to listen on. But then because of the AWS NAT, we had to advertise the actual public IP address. So this was kind of, it's a little bit hard to, let me see if I can change this tab width here. What is it again? Shift width. I don't know how to do it offhand. But anyhow, you can see that there's two elements to this. There's the IP address that we're going to bind to for the listener, and then there's the IP address we're going to actually advertise in the SDP. And so we need those to vary because our public IP address is not the same as the one we're listening on because of the AWS NAT. However, this did mean though that since we're only specifying this one ounce IP address, the SDP was only going to include that one. It wasn't going to include the private IP address, which, if you recall, is the one we need in order to be able to support turn. And so the trick I came up with was to actually give it two binding definitions. The first is just a very the first is the one that gets us non-turn. So we bind to the 0 IP block, which is a little bit not good, but this is kind of a necessary thing we can do to basically bind to something reasonable and advertise the public IP address still. Oh yeah, I apologize. My stream is actually at 720p right now because my computer is terrible. So hopefully that will change soon. But right now I'm a little bit nervous about doing that since I've had a hard reboot twice on the stream, and I suspect if I went any higher, you guys would not see me for much longer. So anyhow, so it's binding to 000 and then also announcing the public IP, and that gets us non-turn. And then the other thing I did was I added another binding that just binds to the private IP address, and that causes it to advertise the private IP address as well. Now I haven't done enough to see exactly what the net effect of this is, because presumably this is what's actually binding to the real thing that ends up being the thing listened on that we talk to, but then this is also binding to all other addresses. So I'm guessing the net impact of this is it's only going to ultimately cause localhost to be a reasonable IP address to connect to as well if you were on the box itself. But there's no other IP addresses really in scope as far as I know, and so I think this is a fairly benign thing to do. But if you were on another server, for example, this might not be what you want. And so a full warning here for people on the stream that might be looking to use this code in the Habitat package I'm about to create. You should know that it is going to bind right now to every IP address if I do it this way. I may have to go ahead and just be a little bit smarter and make it so this isn't what it does by default. But if I were to just take this as it is right now and slap it in there, it would mean your SFU would be forced to always be listening on every IP address that you have available to that server. And so that's probably not something you want. But in our case, it's fine because we only really have the two that are relevant and localhost, which is not really a big deal. So that's kind of the trick I did, and that got me everything I wanted. It didn't seem to work. So that's kind of catching you up on where we left off last time. So now today I'm going to be going over about stuff around how we actually package, deploy, and configure services on both Hubs, Mozilla.com, and also on your Hubs Cloud instances that you might be running. And so this is a pretty deep topic, so I don't really know how far I'm going to get. I'm going to kind of muddle my way through it, but I would consider this to be kind of a crash course, if things go well, on what is called Chef Habitat. So it's a kind of batteries included suite of software and various other things that allow you to kind of take something you want to run on a server and package it up in a way that you don't just run it, but you can actually operate it in a way that's kind of more production ready, if you want to call it that. I'll get more into the details, I think generally speaking, there's probably not a great analog to it that I'm aware of. There were a few kind of projects that came and went. I'd be curious if anyone in the audience knows an analog to something like Chef Habitat. I've not encountered it in an all-in-one thing. Typically, these are things that you cobble together various different projects to do, and in this case, Habitat kind of does all of it. Now, that can be good or bad, depending on how you look at it, but it was something we made an early on decision to use, given that it seemed like the possibility to accelerate our efforts to not have to build or cobble together a solution for some of these problems. And so far, I'm pretty happy with it. Operating the service ourselves with this was kind of a neutral trade-off. There were obviously other ways we could have gone. This is a fairly unorthodox packet of software. I haven't really heard too much about it. I came across it early on because of some of the original authors' prior work. And so it was interesting to me. And you know, for most of the life of the project, it was a little bit unclear if it was really anything more than a neutral choice. And all other things being equal, given its lack of relative popularity to things like Kubernetes and Docker and all of these other things like etcd, you know, all other things being equal, you kind of want to be using the thing everyone else is using. So it was a little bit unclear if it was something that really was the right choice in the beginning. Now, it never really gave us any problems, but you know, like I said, being on the popular happy path is always the ideal scenario if you have if everything else is looking okay. However, once we started getting into the weeds on developing Hubs Cloud, I really do feel that Habitat has been an extremely positive choice. It's effectively allowed us to operate these Hubs Cloud deployments and kind of let you inherit a lot of the work we've done in a way that is very much aligned with how we operate the service ourselves. And incidentally, when we launched Hubs Cloud, you know, one of the things we did was it's all very much coupled to the idea that you're going to be deploying this using AWS CloudFormation, because that's the venue we went about. We ended up using AWS Marketplace for the first target, and that dictates you use AWS CloudFormation. And so really, if we had been using something like, say, Kubernetes to orchestrate the running and other things to orchestrate the deployment, it's a little bit unclear to me how that would play out if we were forced to have an automated management of that. Like, certainly we could have tried using some of the managed Kubernetes offerings on AWS. It's not something I really know too much about, but ultimately I feel pretty good in an absolute sense of how things worked out in regards to how we package, deploy, upgrade, configure, and all of these other elements you'll see when it comes to Habitat with regards to the way Hubs Cloud ultimately works. You may have noticed that when you're running your Hubs Cloud instance, that you will receive updates, that you can configure things through your administrative console pretty easily. And all of that is actually due to a unifying abstraction, in this case, Biome, which is the community distribution of Chef Habitat, the open source, kind of fully open source version of it. And so in that sense, it seems like it's working out quite well. So I'm kind of excited to be able to have, to be able to share more about how it works. And so let's dive in. So as I mentioned, we're using Chef Habitat, or in this case, it's Biome. I'll refer to it as Biome from here on out, but you can just look up all the documentation for Chef Habitat, and you'll see it's the same documentation you would use for Biome. And so we're using Biome for distributing the software. And so we have this Hubs Ops repository, which you can find under the Mozilla repos. And this, from the beginning, is where we started writing what are called our Habitat plans. And so I'll keep a little bit of notes here as I go. Maybe I'll make this a little bit bigger too, because I know some people were saying they couldn't read things so well. So some of you may be familiar with a traditional kind of packaging system. Like if you're running Linux or even Mac or even on Windows, you might download and install software using a package manager. So on Mac, you might use Homebrew. On Windows, you might use Chocolatey or NuGet. On Unix, there's a lot of different ones. And you know, that kind of approach of downloading software and running it through a package manager is one part of what Habitat is about. So it covers packaging. And so packaging in this case, when I refer to that, it's kind of just bundling everything up into a big file that can be downloaded and unzipped onto your computer in a specific place to put it where it needs to be to run it. And I think if you come at Habitat at first glance, you might think that that's really the main thing it's about, but it's actually quite more significant than that. So packages are stored in what's called a depot, And that's really nothing fancy. It's really just what you would imagine. It's a big server that you upload packages to, and then it stores them there so you can download them when you need them. However, a package is more than just its, I'll say what's in a package. And I'll also say before that, how do you create a package? Okay, and so how do you create a package? Well, basically, you know, I'm not too familiar offhand with how you would create like an npm package or a RPM package or a dev or anything you could serve in a Linux. I haven't done it in a long time, so I don't really know all the details there. But in Habitat, the way it works is you create a shell script, and the shell script is called your plan. And so call it a Habitat plan. In this case, like I said, it's running in Biome. But a Habitat plan is a specific shell script that has certain conventions you need to write to basically give Habitat everything it needs to turn that into a redistributable package. So that's the first thing that goes into your package. And that kind of has the things you might expect for creating a binary artifact. It has metadata information, such as who created it, what it is, where you can find the underlying source code and all of that. And then it also has executable code that will be used to both configure, build, and packet and kind of set things up to be compressed into an archive for redistribution. So I'll start with this, and I won't get into what's in the package besides that for now. I'll just talk a little bit more about the plan and show you some of them. So in our case, we wrote all of our plans. Well, your plans basically can be in one of two kinds. They can be either a standalone plan, which is if you say are trying to take an existing piece of code that exists that you don't really control or are not responsible for, and you're trying to effectively turn it into a Habitat package. And then the second kind of plan is ones which are kind of built in, I guess I'll call it. I'm not really sure of the right term, but these are plans that you actually include directly in your repository for code that you're writing, and there's kind of a convention of where and how you put them there, so that people who are using Habitat, or in this case Biome, I'll probably just use Biome and Habitat interchangeably for now because it's going to get tiring to repeat it. But basically in this case, if you include the plan in your repository in a certain place, by convention, that'll mean that people who are using Habitat can use that to package up that code to a package for them to put on their depot. And so you can see if I go to our Reticulum repository, check out here, you can see there's a Habitat folder. And so by convention, you'd stick all of this stuff into your Habitat folder. And then in here, you can see there's a plan, right? And so this plan actually is the only file you would need to hand to Habitat to actually build and generate an archive for that is equivalent to what we run and what we distribute to people using Hub's Cloud. And so you're free to kind of take that plan and build it yourself. And so those are like built-in Habitat plans, I'd call it. They're kind of part of the repository of the project that is that they're being built for. However, a lot of the code we ship is not code we control, and so we have a lot of standalone plans as well. And these are ones that we have taken and basically turned other people's work into Habitat packages that can be run. And so the place where those live is in our Hubs Ops repo, and they're in this plans folder. And you can see there's quite a few of them. Some of these plans are ones we wrote ourselves. Some of them are ones that are slightly modified versions of the ones that Chef and their core plans team have written. But nonetheless, they're all in here, and these are the extent of the artifacts that we distribute to people. For the most part, we're now actually set up to redistribute most of the code that you need through our own plans as opposed to relying upon third-party plans. But generally speaking, it's right now a mix of binaries that were built by third parties, in most cases by the Chef team, and a mix of ones we've built ourselves. So the plan that I'll show you that we're going to be diving into quite a bit more is the Habitat plan for Janus. And if you recall, Janus is our SFU. And so, you know, Janus obviously didn't have a Habitat plan baked into it, and so we had to write one ourselves. And so you can find that again in the plans folder in our Hubs Ops repo, and this is the Habitat plan for Janus. And so I'll just go through this a bit, and then I may kick off a build so you can believe me that it actually does what we say, and maybe on the stream it won't work, but we'll see. So there's a bunch of metadata, as I mentioned, the name and the origin. And the origin is kind of a namespace or a name for all the ownership name for all the packages that you create as your organization or as you as an individual. And the origin is kind of a secured concept. So if you see a Habitat package that has this origin, Mozilla Reality, and you're getting it from a depot that you trust, in this case there are two depots. There's the Chef depot, and then there's the depot that we run, builder.reticulum.io, which I might talk about later. And so if you receive a package from those depots from this origin, you can be sure that it was signed by our keys, and so you can be sure that we created it. Unless, of course, the builder depot was hacked, but nonetheless, well, actually, that's not even true. I believe that you shouldn't even have to worry about that. Yeah, what am I saying? So basically, if you get this, the signature, you basically just need to be sure that the public key is the one that we have. And so right now, you can get that from the depot, I'd imagine. We might want to put that somewhere else just as a backup. So then there's the version information. The version information is relevant because this version is meaningful in terms of how distributions occur. So newer versions are assumed to be the higher numbered Semver versions, and basically that is meaningful because Habitat will actually is something that will upgrade software for you if there's a new version available, and I'll talk more about that in a bit. So then there's just information about the underlying directory structure that will be generated, and the place where you can actually get the original source. And then there's a bunch of dependency information. And so there's two kinds of dependencies. There's build dependencies and non-build, like runtime dependencies. This is very similar to anyone that you might be familiar with, like NPM. You have some dependencies you need to build the package. Those aren't necessary at runtime, and vice versa. Sometimes you need things at runtime. Often you'll need libraries and so on. And so that's where you note these. And now each of these entries is referring to another Habitat package. So the entire Habitat package ecosystem is kind of an island unto itself. There's no coupling with underlying Unix files. It's all self-referential. You're always referring to other Habitat packages. When your software is running on your server, it's running at various different kinds of potential isolation from one another. The most common one that we do is very basic. It's not really as close as you would want to say, like Linux namespacing like containers use and all of that, but it does scope the environment such that it's extremely unlikely that you'll have any dynamic linking or anything like that to other libraries than the ones that were declared as being needed by that software. So it's not like a jail or anything like that, but at the very least, you can be sure that you're not going to suddenly scoop up some new library that somebody installed on the server. And so that's part of the reason why this is a nice system to use. It's not quite as sandboxed as containers, obviously, but it gets you a good chunk of what you get out of that in terms of reproducibility and the inability to kind of have a side effect come along and break your runtime. So, so anyway, these are referring to the build dependencies for Janus. There's a bunch. And then there's a bunch of runtime dependencies for Janus as well. So, so you can see we have a bunch of packages from Mozilla. We have a bunch of packages, a few packages from Core, which is the Chef depot packages as well. And so that's kind of the extent of the metadata that you typically have. And then the rest are functions you have to define. Now, if you don't define these, there's a default implementation. And so if you don't have definitions at all for any of these functions, you kind of get what you would expect for like a generic Unix library. It will do a make, it'll do a configure, it will do a make, and then it will fish out the relevant files. Like for example, that's part of the reason you have this metadata, is that if you have kind of unorthodox build output folders, then you can use this to help Habitat fish out the underlying artifacts from the build. In the case of Janus, we really need to override almost all of these hooks to do something special. And so I won't really get into too many of the details, but this is just kind of boring bash to build and link and all of these things and get the SFU plugin built and then copy files into the proper folder. But by the end of all of this, you should assume that we've basically built a fresh binary for Habitat or for Janus, as well as a fresh binary for the SFU plugin we use. And it's all going to get wrapped up into a Habitat package. And now, because this metadata is here, one of the additional things in the package will be information about the specific versions like down to not just the version number, but also the specific artifact timestamp. It's a version effectively, but it's actually a timestamp of what was bound at the time you ran this plan. And so this causes these to be immutable artifacts. When you run Janus, you're never going to link with any libraries other than the exact versions that you had specified here at plan execution time. And so this means that that Janus binary, that artifact, it's a heart file actually, H-A-R-T. So the output is it's a heart file. So the output of this is a binary you could pass around, and as long as those other binaries that you had as dependencies are available to Habitat's supervisor process, when you try to start this thing, it will fetch exactly those binaries, and then you're going to get those, and you're not going to get a different version by mistake. It does mean, though, if you want to do any kind of upgrading, you have to rebuild the world often. If any underlying dependencies change, for example, you need to build from the bottom up and rebuild the basics and then bring them up to the top, because you can't reuse that artifact with new dependencies. You have to kind of rebuild it all from scratch up to at the level of the tree that changed. Okay, so now I mentioned what's in the package so far. It's a heart file. It includes your binaries, and it includes the metadata and the dependency metadata, right? And that metadata is used to effectively do that sandboxing I mentioned. So when you do this build, it will actually also bake into the package file the various environment variables that need to be set. So for example, since we're pulling in this libsrtp library, which is used for secure encrypted RTP transport, then what will happen is that when the Habitat package is built, it will note what library path that library should be available on, and it'll be a very specific long path that it will assume has been the path in which that package has been installed on the server. And when you actually execute Janus, the Habitat supervisor, which is the process I'll talk about that runs things on your server, will augment the environment of the Janus binary when it runs, so that it actually dynamically links with exactly that library, not some other one, for libsrtp. And so when you build this stuff, there can't be any conflicts in the library's versions. You actually have to resolve, everything has to be resolved to an exact version at build time, because it's going to use dynamic linking on the environment to do that binding to that exact version. So anyway, that's part of the dependency metadata that lands in the heart file. Now there is another very large set of things, conceptually large, not actually physically or whatever you want to call it large in terms of file size, but there's a very large conceptual part as well to a package that might be something you are unfamiliar with, because typically packages don't include this. And this is one of the big reasons that Habitat, to me, is somewhat different than most. And this is your runhooks and configuration schema. And this is actually a really powerful concept, and this is one area that I might just be ignorant on, but this is one of the things that made Habitat interesting to me. And I'd definitely be curious if there are other things out there that kind of encapsulate all of this as well into a package, but I haven't seen it myself. And so I'll take a step back and just talk a little bit about the Habitat supervisor. And again, Biome, if you're running Biome, which people are on Hubs Cloud. So packaging is a critical part, but then the other big part of Habitat is the fact that it actually also is responsible for running and configuring your services on your servers. And it has basically a few roles to play in that sense. It does supervision, as is implied by the name supervisor. And what supervision is if your process is running and suddenly dies for some reason, whether due to an error or due to it catching a signal, Habitat takes its responsibility to bring it back up. And so this is often done by something like, say, systemd or supervisor D, but Habitat supervisor in this case performs this role. The next thing the Habitat supervisor does is configuration. And so this is kind of alluding to what I was getting at as what is the next thing in the package. And so if you're running something on your server, it could be anything from a web server to a database to things like Redis. It could be just a little app that you wrote. Each of these things typically is configured in a different way. Sometimes you have to edit a file, sometimes you have to add a command line switch, sometimes you set the environment. There are all kinds of ways services can be configured in practice, and they're about as varied as software itself. I mean, you could dig up, even in our case, we use Erlang for Reticulum, and it on its own had a very confusing way to configure these kinds of things. And really, when you're trying to run something, that's not something you really care too much about. You really just want to set it up and you want to configure it, and it really shouldn't be an important concern as to the incidental details of how you configure that service, whether it's setting the environment or editing a text file that has a really weird format to set variables to it. And so the idea is Habitat tries to abstract all of that complexity away from you as the operator. And so one of the things the supervisor is also responsible for is landing the various bits that are needed to configure your services. And so the idea is that in your heart file, you also define the configuration schema for that service. And so that's just basically a structural thing that's similar to a TOML file. So it's structurally similar to TOML. TOML is a file format, and it's kind of similar to a Windows INI, if you're familiar with that. And it's basically broken down into sections like this, and keys and values like this. And now this is just the incidental syntax I'm using here. This would be like what you would write in a TOML file for this data structure. However, the key point is that this kind of semantic structure where you have sections and then you have keys, and I believe the keys, and you have sections and you have keys and values. This semantic structure strictly defines how Habitat sees configuration as a concept. And so the way you should think about running your services in Habitat is that your supervisor is running stuff, right? Running a process, running something underneath that's providing the service. And then you're configuring that service through a configuration schema that effectively is semantically equivalent to TOML. So your configuration has sections. So you have services at the top level. So you might have service A, service B, and then you have within that configuration, and that configuration has a section, like each value that you want to set belongs to a configuration section, and then there's a key for it, and then the value you configure. The sections and the keys are determined by the schema defined by the package, right? So to give you a concrete, and the values are the values you can actually set as the operator to configure the service. And so to be more concrete about it, let's say you have a web server, right? Say you wrote your own little web server in Node, and incidentally, the way you set the port to listen on is through an environment variable you pass to your Node process, right? Or you include when you run your Node process. So if you were going to turn that into a Habitat package, what you would do is you would define a configuration schema, and you could come up with any name you want for your sections. I typically will use general. And again, I'm just using TOML syntax here. So I'm trying to communicate this data structure. TOML syntax is just the way I'm doing it. So you would have this section general, and then you have your port, and your port would just be, when you run it, you could set it to whatever you want, but it doesn't really matter. The schema is not going to include the value. The schema is just the metadata about the keys and the sections, right? And so when you create your Habitat package for your web server, you're going to include either explicitly or implicitly, which I'll explain, the schema definition for your configuration. And now when somebody wants to run your web server, all they need to do is just understand that this is how you configure it, is through, if I want to set the port, I have to set the port key under the general section, and that's where my concern ends. What Habitat will do is under the hood, it will know based upon how you built your package that where that port needs to go is in the environment variables that are run when the process starts. And so as the package author, you effectively get to define this interface and abstract away all the incidental details about how configuration needs to be set for that service. And if you recall, there are two kinds of plans really conceptually. There's third-party plans and first-party plans, or as I was calling them, standalone plans, which would be third-party plans, or built-in plans would be first-party plans. And in the standalone plan case specifically, where an author is coming along and adding a Habitat plan to an existing binary that exists or an existing project, one of the primary things as that author will need to do is create this new configuration schema for that service and effectively abstract away the incidental details around how the service is configured. So So that's what we had to do for Janus. Janus, the way it's configured is there's a couple ways. You could use command line switches, or you can drop configuration files. And so, so for the Janus package, we had to define a configuration schema, as I mentioned. And so the configuration schema can be made explicit or implicit, or a mixture of both. And so in most cases, we actually have the schema defined implicitly, meaning that we don't sit down and write a file describing the schema, although I would argue it's probably good practice to do so. But in this case, the way we typically have the schema is just implicitly by the way we write the underlying configuration files that we want Habitat to fill in. And so the schema is kind of based upon what values we extract from the Habitat configuration state, and that kind of dictates what you should set in Habitat configuration to generate the proper file output. So I mentioned there's the run hooks and the configuration schema in the package, and that defines effectively both how the service is run and also how the service is configured. So before I get into the configuration schema and that bit, I'll talk a bit about the run hooks. And so the most important run hook is just run. And so this is, again, part of the package definition. And so you stick if you add a folder here called hooks, that's where you should start adding files that are your run hooks. And when I build this package, Habitat will pick up that hooks folder and use those hooks as part of the service definition. So the only strictly required hook is the run hook. And this run hook is the binary, that's the script that's actually run to start the service. And so the way Habitat works with regards to service execution is it expects the run hook to fork a process, or exec a process, and then sit there and not do anything. It basically assumes standard out is where the logs will go. And so you should write your run hooks such that the standard out is where both standard error and standard out go to. And then that's basically all we do here. So we just have our run, this is our run hook for Janus. We just get standard error set up. We make it so that the process will, this is just a convention so that if you're writing a bunch of bash in here, it'll actually fail out if there are errors instead of just continuing to chug along. And then we exec Janus itself. Now the paths, the environment, all of that stuff is handled for us. So we don't need to worry about the binary not being on the path. We don't need to worry about the LD library path not being set. That's all handled by Janus, or handled by Habitat because of the package metadata. And then we also then pass it a few command line switches. And so, so as I mentioned, Habitat is responsible for giving us the configuration. The operator will have given Habitat the configuration values to use. But now at this point where we're authoring our package, we basically need to start looking up values from the configuration that will be there by the time this package is actually sitting on a server and running. And so it just uses a simple mustache style templating language for extracting and utilizing configuration values that have been registered with the Habitat supervisor. And so in this case, I guess there's really two kinds of macros you would use in this template. There's the one I mentioned, which is extracting configuration values. And then there's also macros you can use to just inject specific kinds of known metadata. So for example, the package version is one that you can look up. In this case, what we're looking up here is the service configuration path. And basically this is a fancy thing where Janus Habitat will set aside a folder on the disk for where configuration files should land for this service. And you don't want to write your run hook pointing to any specific folder. This is where Habitat has been configured for that. And so ultimately we want to start Janus and we want to point it to the configuration file that incidentally will have been generated by Habitat at that point. And I'll explain how. And then, and that's kind of how Janus bootstraps its configuration off of its internal expected files that it has. Cool. So what have we on Ansible config? So I'm not quite following the question, but generally speaking, the values themselves that get filled in are distinctly separate from the kind of configuration schema and the configuration templates. So the run hook kind of provides both the role of a hook and a template because it's filled in with these template variables, right? So it kind of obeys the rules of Habitat templates, which are they're mustache based, and they can pull in both configuration values and they can pull in metadata bits like this service configuration path, which is just where the files that Habitat generates will land. And so in that sense, the schema and the templates are effectively separate and are created at a separate time. They're created at Habitat package authoring time, which is kind of what I'm doing now. And then the actual values themselves are totally a separate process. The values are dynamic and are uploaded to the Habitat supervisor by the command line tool on your server. And so those values can be populated however you like. So for us, when we run hubs.mozilla.com, when we want to update configuration for things, we have an Ansible runbook that we run that effectively runs the Habitat command line tool on one of our servers to push configuration into Habitat. And then ultimately the side effect of that is everything gets regenerated and the services restarted and all that, but that's handled completely by Habitat. All we do is say, hey, Habitat supervisor, we now want our server to run on port 123 instead of 124 or whatever. And then it takes care of the rest. It generates all the relevant files and it restarts all the relevant services given the change we've proposed. So I guess I really am doing a lot of talking here. I haven't done a whole lot of building yet, but I think this is a large body of knowledge. So I'll just keep going over it and we'll see if we can get anywhere close enough to start authoring something by the end of this stream. So the last piece I think I need to cover before I go into authoring this new SFU package is how the templates work. And so, you know, as I mentioned in the run hook, you can use these variables and these mustache things, and that's useful if you say you need to set environment variables, because I can set my variable here, or if I need to pass command line switches. But lots of services don't use those. They also have flat files they expect to be able to find. And so that's the case for Janus, especially because we're telling Janus to read this file. And so the third folder that you can have in your package folder is this configs folder. And this folder is a little bit misleading because it's called configs, but really you should think of it as a files folder that is a bunch of templates. And so we have this Janus CFG file, which is the template for the Janus config file. It's not the actual config file because if you remember, the config file will not really exist until the service is running and the values have been configured in Habitat on your server. But this template lives from the very beginning. It's part of the package and it defines how that configuration file should look and what values should be filled in when the service is actually deciding to run. And so this file is Janus specific in structure. It incidentally is, not to make things too confusing, a TOML file, but there's nothing about this file that dictates it's a TOML file. This just so happens to be how Janus configures itself using a TOML file. And in fact, newer versions of Janus use a different configuration file format. But nonetheless, in this case, it is a TOML file, but you can see we inline the values here using the template handlebars templates. And these things will be inlined by the Habitat supervisor itself, and when it generates the configuration files. Now, one thing to note is that, as I mentioned, newer versions of Janus have a totally different configuration file format. Now, that doesn't really happen very often, but in this case, it has happened. And so, this is a really interesting way to highlight the value of doing things this way, as we're doing with Habitat. What it means is that the way we've configured Janus in Habitat in the supervisor is completely agnostic to how Janus itself expects to be configured. As the package author, I get to decide what happens with the configuration state in the Habitat supervisor, and what my goal is to try to make it so that Habitat can consume that. But the person operating Janus does not know or care about how Janus consumes that configuration. And so what it means is that when Janus, say, changes their configuration file format, and in this case, it was a radically different file format, the operator of Janus will have no idea that that's occurred. They can just update Janus in place to the new version. It'll restart, and their configuration will be reused. The values that they set in the ring will just migrate naturally to the new file format. And as the package author, my only job is to just rewrite this template to just reflect the new file format. But nothing else needs to change. So that's actually a really remarkable property. And it means that when you're operating Hubs Cloud, for example, all of our configuration management is abstracted away. And so that's how you can run a really strange Elixir OTP service and a very boring binary service like Janus that's a giant C++ file, and a Python service, and actually a Haskell-based service, which is Postgres. Each of those, from a configuration perspective, look identical. We just push values to the ring, and the services take care of themselves. And so that's kind of a remarkable property. Now, I don't know if it's something that exists in other ecosystems, but I found it to be supremely useful because it's allowed all of our upstream tooling, such as the tools you use when you actually configure things in the administrative console, to be completely generic, and makes it so that we can slot in new services very quickly and easily without having to kind of do a bunch of incidental work above the package level. So that's the overall overview of kind of some of the core pieces of how Habitat works. And so now the next thing I'm going to do is, that was a weird extension there. The next thing I'm going to do is work on this Media Soup SFU package. So, and now in this case, since this is first party code, it does make sense for us to put this into the repository itself. And so what I'm going to do, so the first thing you do with this is you want to write your plan, okay? And so the plan here is that, the plan for the plan, if you will, is that this is going to be just a very dumb node service. And so the node service in this case, you know, as you saw when I was running it, there's a couple bits of configuration. So the node service, really the primary configuration is on the environment right now. And now the way this works is that, as I mentioned, there's this config file that the service looks for, but incidentally, it also has process env references in the configuration file. And so that allows us to configure the service using the environment. Now, when I go ahead and write the Habitat package for this, I might just cut out that whole thing because there's really no point when you're writing a Habitat package to thread this through the environment because you're already generating the configuration file directly with Habitat. So what I'll probably do is just write the right template for the configuration file and directly inline the values for the Habitat ring state, or supervisor state if you want to call it that, into the configuration file, as opposed to having this roundabout use of the environment to get those values in. So the only reason I would consider not doing that is if there was some value in retaining the existing configuration file as is, and the existing environment-based inlining of the configuration file. But right now, I don't think there's much value. The real value could be if there's some upstream changes to it that we want to pull down and so on. But ultimately, we're going to have to wrangle with those regardless. So I'm going to just go ahead and write it that way. However, the most important pressing concern right now is to just get to a point where it's building. And so, I want to make a Habitat folder. And then what I'm going to do is, there's a known node service that we already run that I'm going to grab. And that one is, let me just think of the right one to pull here. The closest one we have is this service Ito, which maybe I'll talk about some other time. But I'm going to just grab the package, the plan from there as a starting point. And I'm also going to grab the run hook. So I'll make my hooks folder. I'm going to grab the run hook too. And so now we have kind of a really basic V1 of this plan. And so, so I'm going to correct some of this stuff. So if you recall, our name is dialog, and just say a simple media soup based SFU. So now the package dependencies are core utils, node, AWS CLI. In this case, I know we don't need that. That was specifically for the ETA thing. I don't even know why we need Git. I'm going to take that out for now. Let me just make it a comment because we might need it. And now preparing it. This is a little bit of a hack in place so that we rewrite the hash bang references to user bin env to accurately reflect the full absolute path to user bin env. And you can see the note here is that it's because of a Webpack issue. So I'm going to just leave that as it is. Now you can see the build steps very simple. Any Node people would realize this is pretty obvious. And now, and this goes ahead and just removes some of the minified code. I think I'm not going to worry about that for now. This is not needed. And so strip this, that, and the other thing. That's not needed. So strip is a step that the Habitat package builder will run, which is not needed for a Node project, but is relevant for any kind of common Unix binary I believe it does a number of kind of things to the elf headers and various other things. And it may strip debugging symbols too, I think. I'm not sure. But anyway, I'm going to leave that out because we're not building a Unix binary. So that gets us the basic plan that I suspect will probably just work. Oh, and I put the run into the wrong thing, so let me just move that. Okay. Let's see. Okay, so here's the run hook. And so this is actually a fairly involved run hook. So I'm going to just nuke all of this. And again, since the run hook for this leans heavily on the environment for configuring the service. And so in this case, though, as I mentioned, we're not going to do that, right? So basically, we're not going to build this and use the configure. We're not going to use the environment for configuring it. We're going to use a file, which is what it kind of expects. So this path is wrong. And so one of the things I'm realizing is I don't even know if I got a Webpack build going with this yet. So let me just take a look here. I need to confirm the build step actually makes sense. Okay, so let's see. So I actually don't even have a build set up with this yet. So I am gonna probably just cargo cult it a bit for the stream here. So I'm gonna grab this as well from our ETA package here. Okay, and so let's take a look at this really quick. Okay. Give it all the depths. Let's see, path. Okay, so this should be index. There's no entry point, so I don't think I need that. Okay, and then I think this is probably okay. I'm not familiar with this. I'm going to just leave this out for now. Okay, and then I'll just see package. Let me see if package JSON. So this is actually third-party code. So I'm not sure. Yeah, they don't have a build step set up. So I'm going to go ahead and add that as well. So I'm going to just grab it from my package JSON there, and then look for my build step here. And that is very simple, obviously. Just do this. And then let's just take a look and see. Now, in the ETA, we had a little run script. Let me just eyeball that really quick to see if there's something useful there. I might revisit that, but we'll see. And so basically my goal now is to just get an npack build going, a webpack build going. Let's see how it goes. Yeah, so Dom's asking if we need to do a build. Well, we need to pull in the node modules. So I guess I could just suck those in using a copy. So maybe I'll just try that approach. That's a good point. All right, so drop that out for now. Okay, so drop the build step. Just need to see if there's a kind of happy path here. Prefer not to try to like write this all directly on the stream. What I'll probably do is just see if I can fish out a an existing plan, because I'm sure there's a little bit of incidental complexity around getting the files in the right place. So a good place to go for this is there's a Habitat Core Plans repo. And so I usually try to dig up something that is somewhat relevant to what I'm doing just as a first pass. So let's see, questions to the audience. Does anyone know, quick off the top of their head, reasonably sane node-based project you might expect to find in a package repository? I will go out on a limb and say, I cannot think of one actually. Let's see. Yeah. What I'll do is I'm going to just search for npm in the repo itself, and then we'll look and see if we can find one. So, okay, so here's like it's deprecated Kibana. Take a look at that one. Want one that is like a server probably. And there's also this concept of scaffolding, and this is like a kind of a magic thing to package up node services. I'll check and see if there's Ghost. And basically, I don't trust it. So there is a magic path here to doing NPM-based node services, but I just don't trust it. So it's a little too magical for my tastes. Okay, so this is actually simple enough. They just grab in the install step. They grab in the install step the stuff in the package prefix folder, which is effectively the whole shebang, which actually might just be fine. It's not going to grab. I'll eyeball it after the end. I don't know if this is going to grab everything I need or not. And then that doesn't make it. So they're also removing this config folder here, but that's not really needed. They do a different hack for binm, which is kind of funny. And that looks pretty good. Now the other element that might be reasonable to check here is the binders. So that that isn't really relevant for us unless I write a run script. So I'm going to skip that for now as well. Okay, and that all looks the same. Okay, so now I'm going to go ahead and just try the build. And so now to build this, what I'm going to do is enter what's called the Habitat Studio. And I notice we have only a minute or two left on the stream, so hopefully I can at least get a built package. I'm not going to have to get the configuration done, but I'll go over the configuration I write on Thursday. So the studio is basically, oh yeah, I removed that already. I know the stream is a little bit behind, so, oh, sorry, you mean in the plan. Got it, yep, run build, no need for that. Cool, and then, so then I'm gonna enter the studio here while I have like a minute left. And now what the studio is a Docker container that runs, that effectively gets you in a position where all the prerequisite dependencies are loaded and the environment is set, so you can kind of do rapid iteration on your plan file. If you didn't enter this Docker, it meant that everything that's happening right now, which is downloading all the dependencies, setting up the environment paths and all that, would have to happen every single time you made a tweak. So this is just getting that all set up in place so that you just rerun the plan file over and over again until you get what you want, which is kind of a nice feature. So there's a convention when you're in this Docker studio or this Habitat studio, you just can run build, and that'll run the bits to do the build. I don't know why it's complaining about my access token. I'll try doing this one. Oops. Got my token there. Oh, and I also have to set the right. Yeah, okay, here we go. So I just have this continual problem where we have two depots, and I was just on the wrong one basically. I had the wrong credentials for the depot, so I just had to flip over to the right depot and the right credentials for that depot. I'm pretty sure that's all that was going on there. So before I end the stream, I'll just see how this goes. I might take an extra minute to just get it going. And at least this was a good introduction into what a plan file is, what a Habitat package contains, how it kind of works with regards to configuration, and the very, very beginnings of our Habitat package for dialogue, our SFU that we're working on. The next steps from here would be to step out that configuration file, but as a template, and write in the proper inlining of the values, and also, so this is complaining about a conflict and dependency tree. And so the next step would be writing that template and then writing the proper run hook and getting it running. So let me see if I can just fix this too really quick. So this is complaining, as I mentioned, every dependency needs to be resolved to a single dependency because it uses the LD library path to do dynamic linking. And so basically if there's more than one with a given version, that's problematic because yeah, you basically just, that means there's an ambiguity as to what library should be used at runtime. And so what I will do actually is, this is a little trick that I think might fix it. I'm going to switch to our internal Habitat depot, and I think that may just cause things to resolve properly. So because right now there's a conflict. Okay, maybe not. Let me just try this again then. Oops. Let me just grab it. I'm going to update the plan here. So core utils, let's see. I actually don't know why there's a conflict, so let me take a look. So the conflict is between, a bunch of dependencies. So it looks like core utils certainly has a conflict. And so that means that core utils at the root is being pulled in twice. Let's see if we can figure out the other place. It's being pulled in very deep in the dependency chain for Node. And so I'm going to just force it to use the Node version, which is, you know, from 2019, so I don't really care that much. Oops. Oh, I got this cool. Just give me a second. I got to jump out of the studio. My little VM here is full. Okay. A little bit over time, but it's okay. And so now I'm going to just paste in my red core utils. That's fine. Okay, now I should have some space again. Oops. What was that? There we go. Okay. Hopefully a third time's the charm here. I'm going to just go 5 minutes over, just because I feel like I should get to a point where it's not just exploding in my face. It's kind of bad form to end a stream with a giant spew of error messages, right? I suspect that there'll be something else going on just because we have to try to get this packaged up, but at least hopefully it'll be a very obvious problem and not one that might be very confusing for people who are not familiar with Habitat. Okay, so it looks like the dependency tree issue is resolved now. I'm basically forcing it to use a legacy core utils that Node is depending on. Which is fine because it's not very old. It's like a year old at most. And so now it's pulling in Node and core utils, which are the only two dependencies I listed. And now after that, it should start running my various functions I added to the path, or sorry, to the plan for basically just running CI, npm CI, and then grabbing the whole folder and sticking it in the target directory where I would like the output to go in terms of the package, or what files I would like it to put into the package. Okay, so this is looking a little busted. Oh, this is because I don't have Git installed, I believe. So that explains why we needed Git. So, yeah, that's a good question. So core utils, though, it's there from the EDA plan, so I'm perfectly cool with just let's try and see what happens if we take it out. I think core utils might include, oh yeah, that's exactly, it's actually sitting right in front of me. The reason is because, oh, we might not need it now because we're not using Webpack, but typically you need core utils for user bin env, which is something you'll need if you have any kind of shell scripts inside of the project, or the underlying thing uses any kind of shell scripts at all for configure or build or anything like that. So I'm going to go ahead and I'll take this out and I'll take out core utils. I actually suspect we won't run into any problems because we're not using Webpack and we're running Node directly in the run hook. We're not using any other shell scripts, so so this might just be fine. If I get far enough where we're running the build, I'll be happy. Oh wait, why did it stop the build in there? I think I accidentally unsaved that. It'll complain about the that. Okay, let's run it again. You can see it jumped right ahead, see, because I'm in the studio, so I ended up not having to wait. And now it's going to run npm CI. Now, one gotcha, and I actually know where I'm going to get stuck here. So I'm going to leave it. I'm going to leave it at this next part where I'm going to get stuck. Media Soup actually is a C++ project, and part of the npm CI step here, I'd imagine, is going to try to run the C compiler, C++ compiler, and that's not installed. So I'm going to have to go down the rabbit hole of bringing in all the various build dependencies for building Media Soup, and that's kind of where things are going to go next. So I'm going to leave it there. Hopefully this was informative for anyone that is curious about how these things work, and we'll pick it up again on Thursday, where I'll go into the final configuration schema that I come up with, and we'll see if we can even maybe get so far as to deploy it, depending on how far we are with the other prerequisites we needed to get done before that was possible. So I'll see you on Thursday, 4 o'clock Pacific time, and thanks for coming, and I hope it was fun, and I'll see you next time. Thanks everyone. Bye.